All right, so let's review Wednesday's May 27th assignment. So let's review all the gas laws that we've learned. So we learned Boyle's law, which is right here, Charles' law, Gay-Lussac's law, and now finally we're learning the combined gas law. So we've been calculating gas properties using these laws, and in the end, we could combine all these laws to make one law, which is called the combined gas law, where P1 times V1 divided by T1 is equal to P2 times V2 divided by T2. Remember, P is pressure, V is volume, and T is temperature, and you must be in Kelvin. So number one is this. This is your formula for the combined gas law. Okay? So let's move on to number two. So we have a lot of variables. We have 3 variables, and then sometimes we have six altogether, where we are given 5 and you have to find one more. So number 2, it is asked if I initially have a gas at a pressure. So P1 is 12 atm, a volume V1 of 23 liters, and a temperature T1 of 200 Kelvin. I love this problem because the temperature was already in Kelvin. Then I raise the pressure, so that means P2 is 14 atms, and increase the temperature, so T2 to 300 Kelvin. Now we have to find what is the new volume. So V2 is what we're looking for, right? So now I'm just going to take all of my numbers and put it into the formula. So we have 12 times 23 divided by 200 equals 14 times x, which is V2, divided by 300. I'm not going to do the math out right now, but we will find out once you do this side, the left-hand side, multiply by 300 and divide by 14, we'll find that the final volume is 29.6 liters, and you could round that to 30 liters if you like. So that's the answer for number 2. Okay. Moving on to number 3. Number 3, there were a lot of people that got the answer wrong, but I gave it to them because they were off by 5. You'll see right now. If I have 17 liters of a gas, so that's V1 is 17 liters, at a temperature T1 of 67 degrees Celsius, we will have to change that to Kelvin, and our pressure is 88.89 atmospheres. And now the question says, what will the pressure, so P2, what would that pressure be? Oh, so that's X. If I increase the temperature to 94 degrees Celsius, and I'm going to decrease the volume to 12 liters, okay? So 67 degrees Celsius is 340 Kelvin, and 94 degrees Celsius is 367 Kelvin. So I'm going to put these numbers into the formula. 88.89 times volume times 17 divided by 340, not 67, it needs to be in Kelvin, equals X, which is P2, times 12 divided by 367. And then you'll find that your final pressure should be 135.9 atms. A lot of you put 140. I don't know why I still gave it to you, but change it to 135. It should be 135. Okay? And now our last problem, number 4. If I have 21 liters, that's volume, 21 liters of the gas, and the pressure, P1, is 78 atmospheres, and the temperature, T1, is 900 Kelvin, what would the volume of the gas be? So that means I'm solving for V2, X. What happened to the pressure? If we decrease to 45 atms and decrease the temperature, T2, to 750 Kelvin. Again, plug in. 78 times 21 divided by 900 equals 45 times X divided by 750. And then our final volume, once we do our calculations, our final volume will be 30.3 liters, and of course you could just leave it as 30 liters. Okay, you guys did amazing learning and calculating the gas properties of gases. For this month, we know that pressure, volume, and temperature affects the way a gas behaves, and I wish that we were in class so we could show demonstrations of that. But this is the math of the gas laws. Okay, so if you not get any of these questions correct, please resubmit your assignment so you could get the 100. Right? So that's it for gas laws. I hope you enjoy. If you have any questions, send me a message on Jupiter. Bye.